Welcome everyone. Welcome to the third lecture on basics of vectors. So in first lecture we discussed about the basics, what are vectors, a position vector, displacement vector, magnitude and direction. In the second lecture we discussed about how to do the multiplication of vector. And we said that there are two categories in which we can do the multiplication. One is the scalar product or known as a dot product, and we understand the entire chronology of that. Now we have to understand the vector product. In physics, there is one more way to do the multiplication of vector, and that is known as a cross product or vector product. So cross product or vector product will basically give you a vector answer. So let's say you have two vectors, A vector and B vector, and you want to do their cross product. If you do their cross product, you will get another vector which is C vector. Okay? So multiplying A vector and B vector in such a way that you are basically doing a cross product. So if you do A cross B, you get another vector. In the scalar product, what was happening is that when you were doing the scalar product of A and B, you were getting a scalar or basically a number. Now you are not getting a number, now you are getting a vector. So doing a vector product of A and B gives you a vector. So A cross B now is defined as AB sine theta. But since this is a vector, we also have to specify the direction, and direction is specified by n cap. So A cross B is not only AB sine theta, but A cross B is AB sine theta n cap, where n cap tells you the direction of A cross B. And a very special thing about n cap is that n cap is perpendicular to the plane means a surface, which contains the vector A vector and B vector. For example, here I am showing you with the diagram. So you see this blue plane. In this plane, you see the two vectors. A vector is also in this plane. So let's say this is a plane. So this is A vector, this is B vector. So both of these vectors are in this plane. So in this blue plane, you see two vectors A and B. When you did the cross product went perpendicular to this. Perpendicular to this. So basically your A cross B is perpendicular to this plane. So A cross B gives you another vector C, right? So when you do the cross product, you get another vector C. And this C vector is basically perpendicular to both A vector and as well as B vector. And that is very special, and that we see many times in physics. So when you did actually A cross B, you get a third vector C, and this third vector C is perpendicular to A vector also and B vector also. And one of the very interesting thing that I can recall is that EM waves. In EM waves, electromagnetic waves, electric field and magnetic field, when you do their cross product, you get a wave. Wave is perpendicular to both electric field as well as magnetic. So there you see the cross product actually being used in physics. Okay, so that is number one. So let me just summarize this in one line. A cross B gives you a vector. So you decide to do the product of two vectors. One vector is A vector, another vector is B vector. A cross B gives you another vector which is C, and that C vector is basically perpendicular to both A vector and B vector, because that C vector is actually perpendicular to the plane which contains A and B. So that C vector is perpendicular to this blue plane. So any vector which is in the blue plane, C vector is perpendicular to it. Clear? That is the simple idea. So if two vectors are parallel, so let's say I say that okay, there are two vectors which are parallel to each other, then their cross product will always be zero. In the last lecture, we learned that if two vectors are perpendicular, then their dot product is zero. But if two vectors are parallel, then their cross product is zero. So that is very important. Okay. Now you can ask me, sir, that there are two possible directions perpendicular. So this is a plane, then there are two possible perpendiculars. One is this perpendicular which is going up, and another is this perpendicular which is going down. So which one to choose? Either we should choose upward or lower. For that, we basically use right hand screw rule. So you have to basically tight a screw. So let's tight a screw, and it's a very simple thing. So first of all, you have to take your right hand. So this is my right hand, and I do A cross B. So you can clearly see this is your A and this is your B. So first bring your right hand in the direction of A. First of all, ask yourself, what do you want to do? I want to do A cross B. A cross B. So first I will put my hand in the direction of A. Then I will move my fingers in the direction of B. So let me show you that. Thumb goes up. So first put your hand in the direction of A, then move it towards B. The thumb goes up. Now I want to do B cross A. So first I bring my hand in the direction of B, then I move towards A. So then my thumb goes down. So if you go from B to A, so basically you are rotating clockwise. You are rotating clockwise, so thumb goes down. So if you go from A cross B, so you are basically rotating anti-clockwise and your thumb goes up. So A cross B and B cross A are opposite to each other. So A cross B is minus of B cross A. Their magnitudes are same. So the magnitude of A cross B and magnitude of B cross A is exactly same because the magnitude is given by AB sine theta. The only difference that is coming in n cap. So in one case n cap is going up and in second case n cap is going down. Magnitude wise both of them are same, right? So it means both of them are now not commutative, because in the last lecture we discussed that A plus B and B plus A are commutative. In this case they are not same. A cross B does not give you exactly same as B cross A. There is a negative sign in here, and such property is known as anti-commutative. They are not anti, and when you see a negative sign here you call it as anti-commutative. Okay? Whenever you see this happening in physics you will call it as anti-commutative. Now again, one formula is very clear, AB sine theta, but for that you need the magnitude of A and B and you need the angles. And as discussed in the last class, not every time we have that. We don't have magnitudes and angles all the time. Most of the time vectors are given to us in this form. A vector is given as axi cap plus ay j cap plus az k cap, and B vector is given as bxi cap plus by j cap plus bz k cap. Then how do you find A cross B? You use a method of determinant. So first of all, A cross B, you make a determinant. Determinant, how to calculate determinant, I will teach you right now. So you see, you make a two parallel lines. First of all, you write I cap, j cap, k cap. Then you write your A vector, ax, ay, az, and then you write your B vector, bx, by, bz. So you can see below I cap you have your x components, and below j cap you have your y components, and below k you have your z components. Now how to solve this determinant? So first thing first, you write your I cap. You write I cap, and then you cancel the row which contains I cap, and then you also cancel the column which contains I cap. Forget about this. And then you multiply this. Then you multiply ay with bz, ay bz minus az by, ay bz minus az by. Okay, and that is what you see. Okay, then what if this is done? So let me remove this, all this, sorry. So let's remove this. Let me remove this. Okay, now what's the second step? Now you don't write j cap, you write minus j cap. This is a rule. This is a rule of finding it. Then you cancel out the row of j, and then you cancel out the column of j. Now you multiply ax with by, ax with by, bz, sorry, not by, bz, and az with bx, az with bx. So ax bz minus az bx. Okay, and that will give you your second term. Then for your third term, let me again remove this. Okay, for the third term, you again write plus k cap. Okay, plus k cap. Then you cancel out the row of the k cap, and then you cancel out the column of the k cap. And then you multiply ax with by, and then ay with bx, ax by minus ay bx. So this will give you three components: x component, y component, and z component, and that is how you find a determinant. I hope most of you already knew that, because that is a very basic thing that we do in class 11, 12. But fine, it's good to revise everything. Okay. So again, we come to some of the rules, and we will quickly scan through them. I cross I, j cross j, and k cross k will be 0 because they are parallel to each other. I and I are parallel to each other, so they will give you 0. I cross I, j cross j, k cross k will be 0. In the last lecture, we saw the dot product was 1. I dot I, j dot j, and k dot k is 1. But I cross I, j cross k, and k cross k is 0. I cross j will give you k, j cross k will give you I, and k cross I will give you j. And that is done using this circle thing. So you first write I, then you write j, and then you write k. If you do I dot j, you get k. I dot j is k. If you do j cross k, you get I. And if you do k cross I, you get I. Okay. So basically you are moving clockwise, so you will get positive answers. But if I start moving in the opposite direction, so I write my I, j, and k here, but I'm now moving anti-clockwise. So first thing that I do is j cross I. So I will get minus k. Then I move I cross k, so I will get minus j. And then I move k cross j, so I will get minus I. So basically my since I'm reversing my cross products, I will get a negative. Okay. So simple thing. So in that case, you get a negative answer. In physics, we see the cross product many times. For example, in torque is an angular force. Whenever you want to rotate something, you don't need force, you need torque, right? For example, let's say this is a pen, and if I move this, if I basically move this pen like this pen is moving but not rotating. If I want to rotate this pen, I have to give a torque. Yeah. So torque is given as r cross f. Angular momentum L is given as r cross p. R is a position vector and p is the linear momentum. And magnetic force q v cross b, and these all of these formulas you might have seen somewhere in your physics career. So this is where we see the cross product. Another where I tried to give you an example of cross product is electromagnetic wave. That E cross B gives you the direction of wave. Okay? That is also where you see your cross product. Okay? So let's do a quick practice of this, and we will solve this up. So this is a question that you have. You are given A vector and B vector, and you have to find the magnitude of A cross B. You don't only have to find A cross B, but you have to find the magnitude of A cross B. So let's first find A cross B. So how do I find A cross B? So I write I cap, J cap, K cap, and I put two parallel lines which basically represents determinant. Then I write my first vector. The first component is 3, so I write 3. The second is 1, so 1, and third is 2, so 2. Similarly, my B vector, so the first component is 2, second is minus 2, and third is 4. 4. And then I just simply solve my determinant. You first thing first, very simple. You cancel your first row and first column. So 1 into 4 will give you 4. Minus 2 into 2 into 2 minus 2 is minus 4. Minus minus becomes plus. So 4 plus 4. Similarly, you can find this determinant out, and I will have this for you. So the answer that you get for A cross B is 8 I cap minus 8 J cap minus 8 K cap. That is your A cross B. I can take my 8 common, and I will get I cap minus J cap minus K cap. Now I need to find the magnitude. Best thing about the magnitude is that if something is common, don't touch it. Don't touch it. If something is common, just let it be like that, and find the magnitude of rest of the thing. So how do you find the magnitude? A ka square means ax square 1 square plus ay square 1 square plus az square 1 square. 1 1 1 1 square 1 square 1 square is under root of 3. So your final answer is 8 root 3. So the magnitude of A cross B is 8 root. So that is your option number B. Another question which is very interesting, and this question is basically asking you to do cross product but in a very different way. Okay, they're asking you to do cross product, but way of asking has been little bit changed. So what they are asking that what is the unit vector which is perpendicular to this vector and this vector. So you have to find some unit vector which is perpendicular to both of this. So which vector will be perpendicular to both of this? If I do their cross product, if I do the cross product of these two vectors, then I will get another vector, and that another vector will be perpendicular to both of them. I will repeat this. They told me that find a unit vector which is perpendicular to both this vector. So if I do the cross product, I will get another vector, and that vector will be perpendicular to these two vectors. Okay, so all I have to do is cross product. So let's do the cross product, and I will not show the mathematics, but very quickly I will leave that for you. So I will say I cap, j cap, k cap. Then I write my first vector. So 2, 2 minus 1. And then my second vector 6 minus 3, 2. And then I solve this determinant, and that is up to you. If you solve this up, you will get I cap minus 10 j cap minus 18k. But this is a vector. This is not a unit vector. They asked me to find unit vector. It's very clearly said that what is a unit vector? Basically the direction. And in the first lecture, if you remember, whenever we have to find a unit vector, we divide the vector with magnitude. So you get a direction. So if you divide the vector with magnitude, you get a direction. So I already have a vector. So I have a vector. I just need to divide by magnitude so that I get a unit vector. So if I divide by magnitude, how do you find the magnitude? 1 square plus 10 square plus 18 square, which is under root of 425. Under root of 425 can be written as 17 into 25. And 25 can come outside the under root, and outside it will be 5. Under root of 25 is 5, and under root 17 remains inside. So this is your answer. Let's check which option is this. So this is your option number C. Okay. So indirectly they asked us to find the cross product and then also find the unit vector. The unit vector is that vector divided by magnitude. Okay. So that was the case. Now again interview questions, or you can say the basic understanding of mathematics. What is a geometrical representation of a vector? How do you represent, what is the meaning of or geometrical meaning of cross product or a vector product? And that meaning is basically coming from, if you find a cross b, and then you find its magnitude of a cross b, then it represents the area of parallelogram whose sides are a and b. So basically you can make a parallelogram with two vectors. One vector is a vector and one vector is b vector. Okay, if you make a dotted line parallel to a vector, this is this, and another line which is parallel to b is this. Basically this line and this line are same, both of them are a. Similarly b vector, this line and this line are same, so both are b. So this is a parallelogram, right? This is my a, this is my b. Okay, this is also my a, this is also my b. So I get a parallelogram, and I want to find the area of this parallelogram. So what I will do, I will just do a cross b and find its magnitude, and that will basically give me the area. Area is nothing but just simply the multiplication of a cross b, or not multiplication, the cross product of a cross b, and then I have to find the magnitude. Sometimes they also ask the area of the triangle, because if you cut a diagonal in this parallelogram, you get two triangles. This is one triangle, this is another triangle. So a cross b can also make a triangle, right? So sometimes they ask you to find the area of the triangle. In that case, area of the triangle is just half of the area of parallelogram, because you see, if I cut a diagonal, I will divide my parallelogram into two triangles. So the area of one triangle is half of the total area of the parallelogram. So area of triangle is half of area of parallelogram. Area of parallelogram is a cross b determinant, magnitude. So let's do a quick practice of it. So again, they are asking you to find the area of parallelogram whose sides are represented by this and this. So they give you the two vectors who are making this parallelogram. So they are asking that what is the area of this parallelogram. So first thing first, you do A cross B. So I cap, J cap, K cap. First vector does not contain any I cap, so 0. It contains 1 J cap, so 1. 3 K cap, so 3. Then the second vector 1 I cap, 1. 2 J cap, 2. Minus K cap, minus 1. If you do solve this determinant, and which will be your work, you get this answer. This is your determinant. Sorry, A cross B. That is not sufficient. You just don't have to find A cross B. You have to find the magnitude of A cross B. How do you find the magnitude of A cross B? 7 square, which is 49, 3 square, which is 9, plus 1 square, which is 1, and under root of that. So this will become 49 plus 9 plus 1, which will be under root of 59. So that is your final answer. Under root of 59 is your final answer. So your option number B is correct. Okay. So that is, I think, all about cross product. In the next lecture, I will start a very interesting thing, which is basically how to add the vectors. And I will teach you 2 to 3 different ways to add the vectors or finding the resultant of the vector, which is very, very important. So I will see you all in the next class. That's all for this lecture.